Hello all, welcome to the design pattern series. Today we are going to look into facade design pattern and we will go through all the details and how to implement it. So let's start. Let's go through the theory part first and then we will look into example to understand how it works and how to implement it. Yeah. So in today's video actually the topics which we are going to cover are what problems the facade design pattern solves, how facade design pattern works and how this pattern can be applied in your code. So we will look into all the aspects of the particular design pattern. Okay, now moving to the introduction part, the facade design pattern comes under structural design pattern, and facade design pattern actually is useful when you want to handle complex systems which has multiple independent subsystems. Like example will be multiple classes or modules to achieve the desired functionality. So you want to do something, you will need to call multiple classes and subsystems to perform that particular task. And to handle such situations, this pattern actually works. And this pattern, how this pattern works, is by providing a simple interface for subsystems which are poorly designed or complicated, and it does it by hiding the implementation details. In other words, it provides abstracted view of subsystems by hiding its complexity, which result in offloading all the load from client classes or the system. And as of now, this might not give you a complete picture about facade design pattern, but during the implementation phase where we will see the actual example of it, that time all the doubts will be clear. And when we save, it gives us the abstracted view. Actually, this is needed because in case you have number of methods or classes which has a different part of the functionality, and if you give it to the user to consume it, then it will be difficult for the user to use it because he will need to check and decide which method to call and when to call. So the ordering will also need to be decided by the client, and which will result in by end of the day like class being tightly coupled with the multiple classes. Simple example if to be given will be like if a client class wants to save data in database, and if you have exposed separate method for each step. Example will be like one method for validation, the other one for logging the data, other one for adding the data, and so on. So there might be multiple checks you want to perform, or you have or few couple of methods. So in this case, in case if you all these methods actually you provide to client to consume, and then client will need to decide like which method to call and at which point. Because in case if he fails to call the validation method, and while saving the data we don't have proper like check to see if the data is correct or not, or whether we must store it in database or not. So in that case wrong data might go to the database. So this kind of things might happen. So to come over such situations, what we can do is we can provide a class which will take care of all the steps and provide only one method like add data, which will take care of calling all the steps. So this particular class, what it will do, it will call all the intermediate steps in a particular order. So client don't have to bother about calling them. What client will do like client will call this new facade class, and using that one method only, he can perform all the operations. And this will also remove the tight coupling from the client classes. By this way actually we are making sure that client class is calling only one method and not the complex system directly. And even if in future one more client comes who needs same functionality, so it can utilize this facade class only. You can use the facade pattern when you need to provide simple interfaces as an entry point to access complex systems. Now let's look at the examples actually which we are going to take. First we will see the presentation of the problem, and then we will go to the actual implementation. Okay, so this is the problem representation for our today's demo. So actually uh, the project actually which I have created for today's demo is a device management system. So what it does, it collects the information from the device. Device will be like laptop or computer. So what it does, from the system, it gathers all the required information like what softwares are installed, what is the version of the software, or the serial number of the device, RAM capacity, hard disk space. Then it also gathers information related to legacy devices. See, I'm using some external devices which I connect to my laptop to carry out certain operations. So I'm calling those devices as a legacy devices. So those devices will also have some information which will be stored with my laptop, or that information may be with the legacy devices only, and my laptop can communicate with them to gather that information. So this kind of functionality this particular project is having. So as of now, in a normal scenario, what we are doing is from our client class only, we are providing him all the methods to gather this information like legacy device registry info, legacy device version info, so on. So right now, the client is calling all these methods directly. So he has to instantiate all the classes and then call the respective method, gather the information, and create an object, or I will say device info object from that, and then it can pass it to database. So now, if we are creating all the instances of these classes in our client class, so somehow we are tightly coupling all these subclasses with our client, and it will become complicated because having these many instances, then calling each other method in case if we forgot to do something or call one method, so that then we will be in problem. And in case if in future there are any changes to any of the method or any of the class, so that time we will need to touch our client as well, so which is not ideal. So to solve this, we are going to use facade design pattern, and how it helps. Let's go to the next slide. Yeah, so this is the solution actually which we can design to handle this situation in more better way. So what we have done is now we have introduced a facade class. We call it as a device facade, and then we have created one interface as well. So we want to make our system loosely coupled. So what we have done, we have introduced one interface as well, which client will be using. And then we have created one class, that is device facade class. And this device facade class actually will be communicating with all the subsystems like legacy device registry info, legacy device version info. So with all these classes, this facade class will communicate. So it will have the responsibility of instantiating and then calling the different methods, gathering that information, and then what are the responses receiving. So collect all that response and pass it to the client. So we are offloading the task, this entire task of creating instances and gathering information from client to the device side. And in case if in future some other client comes requesting the same operation, he can directly call the device facade class. So let's now go to the Visual Studio and look at the actual implementation of this. Okay, so this is the sample program I have created for demonstrating facade design pattern. This project actually, this is for managing the device information. So device status information. So when we say device status information, so what it does, from registry or from system info, it fetches the basic information related to devices like RAM size, what is the serial number, then what are the different softwares which are installed, and what are the different software versions, as well as update history. And then there are two more scenarios where we fetch information related to legacy devices. And when we say legacy devices, those are the devices, old devices which we connect to our laptop to carry out certain operations. So when we connect those devices, its information will be collected by system, and that information we will be fetching via these classes. So as of now, you can see this is our client class program.cs, because this will be actually display fetching out this information. So as of now, let me run this program and show you the output. Yeah, so you can see it has started fetching out the information, and the logs related to fetching are are outputted on the console, and you can see the fetching operation is complete. So now for fetching all this information, what we needed to do is we created instances of all these classes in our client application or in our client class, and then we are calling the respective methods and fetching all that information and collecting that all information in one object, and then we'll pass it to database. So as you can see, our client class is now tightly coupled to this all these classes. We are instantiating it here. So this is the extra headache which client is having. So this is not a good practice, and in order to solve this kind of issues or problem, because in case in future if something changes, or we change this method name, or if this method starts accepting certain argument or something, so in case of signature changes, so in those cases we will need to touch the client code as well, because that time this method won't be available, so we will need to make changes in client code as well. So to avoid this kind of scenario, facade design pattern actually comes handy. So how to implement it? Actually, I have already done the code changes for them, and we'll just show it to you directly. So to handle this scenario, what I have done, I have created one interface. This is iDevice information. It has only one method declaration, that is get device information, and this particular interface is implemented by this device facade class. Now in the implementation of this get device information method, we have done all the things which are required for fetching the information for different devices, or we'll say different system information. So whatever we were doing so far in client class, we have moved that to this device facade class. So this class will now hold the responsibility of calling all these classes and gather all the information and just send the final output to our client code or client class. So now once we have done these changes, so now to consume that, we only need to line of code. So I will do those changes right away. So let me just remove this much code now because it is not required anymore. Yeah. So now we just need to instantiate device facade. So yeah, so instantiate it and call the respective method. Now let me run this program again. Yeah, so it has started fetching out all the information and you can see same logs were logged here. So this way actually we have now moved all the complicated subsystems, calling all this complicated subsystem and everything, all that logic to this facade class. So client don't need to worry about it. Client don't need to worry about like how to call them, which class to call, which method to call for which. So all these things, all those things will be taken care by now device facade. So this way, uh, this design pattern helps us to resolve this kind of complicated scenario. Yeah. So I think that's it for the example. So that's it for today. We went through all the details for facade design pattern. In case if you like this video, please do share and subscribe to my channel, and please hit the like button in case if this content really helps you. Thank you.